Hi, this is just another video to go over a few more examples. One of them is obviously from your textbook, as it says on page 629. So if you open up your books to page 629, we're going to look at question 7. It's kind of in the middle of the page, and I just want to walk through how do you solve a question when there are variables in the denominator. Let me change the size of my pen for a second. So we now have variables in our denominator, but we're going to follow some of the same methods that we did before, except one of my first steps that I really want to focus on is I really want to factor first. And the reason that I want to factor first is it's going to really help me find the lowest common denominator quickly. So for that first equation, I notice I can take out a greatest common factor of an x, and the rest of them I actually can't factor. So I'm just going to rewrite them. And again, it's really nice to see because now I can see what my lowest common denominator is. And as many of our methods were from our bell work, finding the lowest common denominator might be my next step. So I'm going to show you again multiple methods for solving these. And I would create a common denominator. I'm going to multiply this middle term by x minus 2, both the top and the bottom. And I'm going to multiply this last term by an x, both the top and the bottom. So I'm just going to rewrite so it's a little bit less messy, and I have 10 over x times x minus 2 plus 1 times x minus 2 over x times x minus 2 equals 3x over x minus 2. And again, you can use any of the methods that we saw in our bell work to continue to solve this question. So I'm going to use that first method for this problem, and then we'll use the second method for another problem. Since they all have the same common denominator, I'm actually going to set this equal to 0, and then I'm going to combine all of them together. So the first thing I'm going to do, and I could have done this at the very beginning, like we did in our bell work, is I'm going to subtract this fraction 3x x times x minus 2 equals 0, and now I'm just going to rewrite all of those terms. Again, this is that middle fraction minus 3. All of that is over our common denominator now. Now I'm going to combine like terms. So I have a 10. Again, there's just a 1 here, so it's a 10 plus an x. So really, I don't even need parentheses back here. Some people just like to put them in to have them there. But I have a 10 plus x minus 2 minus 3 all over my common denominator equals 0. So I have an 8 minus a 2x over my common denominator. And then like we saw in our bell work, I can multiply both sides by the denominator. And if I multiply both sides by that denominator, on the left side they will cancel, leaving you with 8 minus 2x equals 0. And now all I have to do is solve. I'm going to add the 2x to both sides, and then I'm going to divide by 2. So x equals 4. One of the things that we have to be aware of, though, is when we have x's in the denominator that there are restrictions. Again, we can't divide by 0. So it's helpful to see our factored form of our denominator and say, well, x can't be 0, because that would cause this to be divided by 0, and x can't be a positive 2, because that would be divided by 0, and likewise, those two numbers make the first. So we do want to list restrictions as part of our steps, and that only happens when you have sort of asymptotes or holes in your denominator. So what I'd like you to do at this point is I'd like you to pause the video. I need you to stand up and go talk to your teacher and ask for a copy of the 8.3 skills practice. That is your homework, because the next problem I'm going to go over is right off of the homework, and I want you to have the sheet in front of you. So pause the video here and go ask your teacher for the homework. You should have your 8.3 homework in front of you right now. And if you flip to the back side of the homework, this is question 10. And I want to go through question 10 with you, very similar to the previous example, but I want to make sure that you have one on your homework so that you're not frustrated for later. Hi, so I hope the video is okay. I just had to hit pause for a moment and I might have skipped. But this is 10 from your homework. And again, just like we were doing before, in both methods, we really do want to factor first. So when we're looking at question number 10, there's nothing that I can factor from that first part, but I can take out a greatest common factor from this second rational expression, and there's nothing I can do here. Likewise, the methods that we said were always kind of related to figure out your lowest common denominator. So again, lowest common denominator means this first equation needs an x, and this last equation needs an x plus 3. I find that personally to be the fastest thing to do, is to figure out what your lowest common denominator is. But then if you remember from our Bell work, that second method that we learned was to multiply every single term by the lowest common denominator. So if I multiply this 2x, if I multiply it again by the common denominator, then I have this. If I multiply the middle term by the common denominator, I have this. And if I multiply this last value by the common denominator, so this last term was this, if I multiply it by the common denominator, I have this. And if you remember in our Bell work, what that allowed us to do is to say, oh, this cancels out this cancels out that, those cancel, and those cancel. So whenever we multiply by the lowest common denominator, now we are left with 2x plus 6 equals 1 times x plus 3. And it's very nice when you have your common denominator, if you multiply by that common denominator, notice they all canceled out. Really, I'm just left with the numerators, and now I'm left to just solve. So distribute the 1. Now I'm going to subtract x from both sides. I'm going to subtract 6, so x equals -3. Now before I can decide if that is a solution, again, I have to talk about my restrictions. So sometimes people do this as like the second step after they've factored, but x can't be -3 because that would make this first fraction divide by 0, and x can't be 0 because that would make this fraction divide by 0, likewise the same. Now notice that's what we found. We actually found x equals -3. We refer to this as an extraneous solution, which means it's something we absolutely solve for correctly using all of our algebra steps, but it can't be an actual solution because it's one of our restrictions. So you can either say that this has an extraneous solution, or you can say that it has no solution because there's not a number that actually works to solve this equation. So I wanted to show you those two examples. Your homework is to finish the 8.3 skills practice. If you need more review, remember to check the website again. There's another review video on solving that walks through kind of another method or another way to do it. And then when I see you in next class, we're going to continue to review solving as well. So if you have any questions, please stop by, come in for resource, ask any of your teachers, and we will try to help you. Thanks.